Okay, for the HBL and the PTM classes which are affected by these two events, so what we are going to do is we're going to record the initial part of organic chemistry, which is the introduction, and then we just go through that naming part through the video. Okay, just a quick recap about organic chemistry. So there are many different functional groups, and with each functional group, it consists of a series of members, and the members all together make up the whole homologous series of the functional group. So we have a series of compounds belonging to the same functional group with the same general formula, which is usually represented by something like CnH2n kind of formula. And that formula gives us an idea of the number of atoms, carbon, hydrogen, oxygen atoms present in the structure or the compound. And we find that between the series of members, every member will be longer than the previous member, but a common structure unit, which is a CH2 unit. Now, that's the feature of a homologous series. So with the same family, or where we say same functional group, we will expect that the homologous series members, all of them should have the same chemical property. However, because of the increasing CH2 unit, that increasing CH2 unit actually increases this portion of the molecule, the alkyl portion, and makes the alkyl portion longer, affecting the London dispersion force. So we will see stronger London dispersion force as the length of the carbon chain increases. And not only that, we will see that they are getting more and more insoluble in water, because this alkyl chain, right, is what we call hydrophobic. So they are afraid of water, or they are not miscible, does not mix well with water. So as the carbon chain increases, we will expect that the London dispersion force increases, and the increasing character of insolubility in water will be seen. Okay, so as later as we look at the naming, it's important to know how to name the stem according to the number of carbons. So if there's one carbon, we have to learn the alkyl chain as mete, then 2 will be ethane, 3 propane, and so on and so forth. Okay, so this is expected for you to know. Okay, so as mentioned earlier, we expect them to have similar chemical properties but differing physical properties as a result of the carbon chain length increasing and affecting the London dispersion force, which makes it getting stronger. Okay, so it affects properties like melting point, boiling point, viscosity, and density. Okay, so you can see that as the chain length increases across the down the homologous series, the compounds now changes from maybe a liquid or from a gaseous state to a liquid state, and then eventually for very long chain it could be a solid. Okay, so how do we represent organic molecules? You see, we know the general formula. The general formula, let's say, was CnH. Different functional group has different general formula. So let's say for alkanes is CnH2n plus 2. For alkenes is CnH2n. Okay. And for alcohol, it could be CnH2n plus 1 OH. Sorry, it should be plus 2 O. Okay, so you have your alcohol, something like this. So original position of the OH is replaced by an O, but you also bring along an extra H along with it. Okay, so we have the general formula. Now, general formula, if you look at it, it doesn't tell us a lot of things. It allows us to know how many C and how many H and how many O present. So, which gives us an idea of the molecular formula. So the molecular formula tells us how many carbon to expect, how many hydrogen to expect. Okay, now if the molecular formula is simplified into the lowest term, then we get the empirical formula. So example, if I have a CH4H8, which is a butene, if I give it in the lowest term, I'll get CH2 as an alkene, empirical formula. Okay, so but you see CH2 doesn't tell us much thing, but at least C4H8 tells us that there's 4 carbon, 8 hydrogen atom that I must be drawing. Okay, so take note, members of the same functional group or same homologous series, they have the same general formula. Okay, but in terms of empirical formula, only alkanes have same empirical formula. So all members of alkenes will have the same empirical formula. Or of course, if you don't use alkene, another one could be cycloalkene. So only these two functional group members will have the same empirical formula. Okay, the rest will not have the same empirical formula. Okay, only alkenes and cycloalkanes, all the members have the same empirical formula. Okay, but whereas the alcohols, carboxylic acid, etc., the different members of the homologous series may not have the same empirical formula. Okay. Okay. Wait, let me. Okay. Next, let's look at the structural formula, because by knowing that the formula is C4H8, it doesn't tell us how to arrange it properly. It doesn't give us an idea of how to draw, where to put the double bond, where to put the functional group. So we need the structural formula to allow us to see how atoms are connected. And out of the structural formula to see how atoms are connected, there are 4 different ways to present it. One way is condensed formula. Condensed formula, that means you will write it out in a line, not showing any bonds, and then you may not be able to visualize the branching that easily. So an example of a condensed formula could be like CH2CH3. So like this is an example of a condensed formula. Okay, this split formula will actually show all the bonds, and the split formula will show all atoms. So this shows all the bonds and all the atoms. Must show all the bonds and all the atoms. So be very careful, especially when there is OH. Okay, many students always forget to expand out the O bond with the H. Okay, because we are so used to writing OH that we always forget to do this. So this is wrong for the split, and this is correct. So another name for the split, if sometimes the question may phrase it a bit differently, is they may call this as a full structural formula. So if you have a name called full structural formula, it means the split formula. Show all the bonds, show all the atoms. Okay? Now, stereochemical formula is, or we will call it, is like the 3D arrangement. So when you're drawing it, right, because most of the carbon atoms are actually tetrahedral, so they are actually 3-dimensional. So when we're drawing a stereochemical structure formula, we're actually showing the 3D arrangement, and then visualizing the bonds that's sticking out of the plane, visualizing the bonds that's sticking out from the back of the plane. Okay, so therefore we will have drawings that look like this. The 2 dashed line represents atom within the plane. This H and Cl are on the same plane. And then the thick wedge that maybe you'll be drawing, is actually telling us that this group, maybe fluorine, is sticking out of the plane. And there's another group that we draw in this manner using this dash bond that look like this. Okay, and that is showing that bromine is actually behind the HCl plane. So you can visualize this as in a plane, and that's the plane, and bromine is behind it, and fluorine is in front of that plane. Okay, so we draw stereochemical or 3D usually when we need to show stereoisomers. So for SL students, you don't learn stereoisomers, but for HL students, you do have to show stereoisomers. Skeletal formula is the drawing representing the carbon and hydrogen in form of like sticks. So for example, a skeletal formula may look like this. So how do we interpret a skeletal formula? Basically, all the carbon and the hydrogen bonded to the carbon are not shown. Okay, but if we have a carbon, if we have a hydrogen that is bonded to oxygen, then we have to show. Okay, or we have a hydrogen that is bonded to nitrogen, we have to show. But if the hydrogen is bonded to a carbon, then we do not show. Okay, so the carbon and hydrogen that are bonded to the carbon atoms are not shown. So where are the carbon atoms? The carbon atoms are at the edge, at the corners or the edge. Okay, so this is 1, 2, 3, 4. So we have 4 carbon atoms. So basically the edge of the line is a carbon atom, and all the hydrogen bonded to the carbon atoms are not shown. So for example, if I look at the first carbon atom here, I actually have to know that there's 3 other hydrogen bonded to it, even though it's not shown, because I understand that a carbon has to form 4 bonds in order to achieve a stable octet. And therefore, even though they were invisible, you need to know that there's actually 3 hydrogen atoms here. So say for this carbon over here, we have 1, 2, 3 bond being shown. So knowing that a carbon needs to form 4 bonds, so there is a missing hydrogen or invisible hydrogen here, but we need to know it's there. Okay, so we basically do not show the carbon and the hydrogen which are bonded to the carbon. So what happens if, let's say, if you are drawing a carboxylic acid or of an ester, then it may end up looking like this. So you can see I need to show the O, but I'm not showing all the C and the H. Even this C in the COO is all not shown, okay? Okay, so I can understand what are the different representation. I would tell you that in exam, avoid using molecular formula, really. Okay, it's not clear. It doesn't even tell us much information. So as much as possible, minimally displayed formula. Okay, showing all the bonds, showing all the atoms. But if you really don't like displayed formula, it's because it's very tiring drawing all the H, then condensed formula. Okay, condensed formula. Now, how about some student will tell me, oh, I want skeletal formula. Of course, if you can draw skeletal formula, you can go ahead and draw. Okay, for those who cannot, find it very hard to visualize skeletal formula, then you draw full structural. Okay, but even though maybe for those who find it a bit hard to visualize skeletal formula, take note that there is an increasing trend that IB is using skeletal formula in their exam questions. So I think past few years, most of the organic structures were drawn using skeletal formula. Okay, so it doesn't mean that you have to follow and draw, but at least you should be able to interpret if a drawing is given to you in terms of skeletal formula. You must be able to like read and understand it. Okay. And then the stereochemical formula is more for the HL students. We need to draw this whenever we are showing stereoisomerism involving enantiomers. or what you call optical isomers. Okay, once we cover the optical isomers part, then you will understand. But by default, if any question asks you to draw enantiomers, or by default, if any question asks you to draw optical isomers, it's by default stereochemical drawing, 3D, okay? Even if it's not like explicitly spelled out in the question. Okay, so with that, let's look at this and then complete this very quickly. So the easiest way, of course, is to draw the full structural formula and then fill up the rest. Okay, so if this is the structure, then count all the, how do you do the condensed formula? What you read is what you write. So what you see, you write. What you see, you write. What you see, you write, and so on. Now, sometimes in the condensed formula, if there's anything like branching like this, or there could be like branching like this, you can use brackets. You can use bracket. So for example, let's say this one is the structure that I will write in C like this, CH2 bracket Cl, CH2, then CH, then bracket CH3OH. So you can use bracket. So the bracket is like telling you it's like a substituent there. Okay? Because if you sometimes write all in a straight line, especially then you may mistakenly put the CH3 in the main chain. So you can use brackets to help you. Okay, so next, let's look at the scatter formula 1, 2, 3. And with an OH. So 3 carbon and an OH. The H is only shown when it's bonded to non-carbon atom. Okay, ethane, 2 carbon and alkane, all saturated. Now, don't draw me this fishbone diagram. I call it fishbone diagram because it looks like just like sticks only. I mean, after a while, if you do it during your own notes, it's fine. But during exam, you must always put in the hydrogen. Nobody will mark this fishbone diagram, okay? You either put all your H in, but I understand sometimes along the way in class, we want to draw fast, and then we want to finish our work fast. We draw that diagram. But during exam, you have to put in all the hydrogen. Okay, so with that, then you can read out the formula, condensed formula CH3, and I read another CH3, and then draw the scatter formula will be just like that because 2 carbon, that's all. And the molecular formula, count how many C I'm seeing, C2 carbon and 6 hydrogen. Any way to simplify this? If there is, then the empirical formula will be different from the molecular formula. Okay, and then do the same for pen 1 in and the rest now, okay? So pen 1 in. Double bond and number 1, every carbon has 4 bonds. So make sure you fill up the bonds to make sure it's always at 4 and not like this. And then you have 5 bonded carbon, okay? Okay, you can then fill in all the hydrogen because the question asks for displayed formula. So you have to fill in. And then what you read is what you're going to write out for your condensed formula. I'm reading a CH2, and then I'm reading a CH. I'm reading a CH2. But if I'm lazy, I can put a bracket CH2 bracket 2. Okay, but let's say if I don't want that, I can write that 2 times, and then I put it this. Okay, so that means what I'm saying is that if you don't like this, then you can also write this. Now, because consecutively, this CH2 is appearing 2 times, so I can bracket CH2 twice, and then CH3. Now, but if you find it 2 times only, just must as well write it out, then just write it out. Okay, then the scatter formula will show 1, 2, 3, 4, 5 carbon. And then on the first carbon, there's a double bond. Okay, and then we count 1, 2, 3, 4, 5. So C5. Anyway, you can either count or you remember it's an alkene. So if you remember it's an alkene, it's CnH2n. So it will be C5H10. So CH2. Remember every alkene only, and cycloalkane always have the same empirical formula. Attenuate acid. Now remember, if you do like this, like what I just did, then it'll be wrong because the O and the H bond is a bit shown. So with that, the formula will be CH3, COOH, and you draw it out. 2 carbon, then how? How to put the OOH, right? So you need to brush down OH, double bond OOH, okay? And then your formula count, your H will be C2H4O. And any way to simplify it? If no, there will be same C2H4O2. Sorry, C2H4O2. C2H4O2. So there will be a way to simplify it. So it will be CH2O. Okay, that 2 oxygen, butan 2O. So draw your carbon, 4 carbon. And number 2, there's an alcohol. So O expand out H. Okay, always expand out the O and the H and put in the remaining hydrogen. Okay, and then write down the condensed formula, CH3, CH. Now you can put down this way, CHOH, or you can put down as CH3, CH bracket OH. Then CH2, CH3. I mean, the bracket is more for yourself. And then when you draw a skeletal formula, 1, 2, 3, 4. So 1, 2, 3, 4. Oh, sorry. Okay, and number 2, there's OH. So you can either branch up OH, or you don't like to branch up, then you branch down. But branch down is quite ugly. So you branch up. Okay, 1, 2, 3, 4. So this is your butan 2O, and then you got this structure already, and then now the molecular formula C4H. Then O. Then if C can just make it simplest term, if not, then it will be C4H10O for empirical formula. Okay, so that's what we have done. Okay, so we have seen the functional group. Now we're going to the next part, which is the naming. Now, before we go to the naming, it's good to know that at least recognize the functional group first. Okay, know what are the special features, like hydroxyl group, like aldehyde. It will have this group, which is the carbonyl group. And this carbonyl group is special. It has this hydrogen bonded to it, so COOH. That's our aldehyde. Okay, so a very quick recap. Alkanes is actually an unsaturated hydrocarbon. So you can see under the category of functional group is blank. It has no functional group, actually, it has no name. Alkene, yes, we start to see this feature, C double bond C. The name of this functional group is not alkene. The class is alkene. The name is alkena. Okay, so the name of this functional group is called alkena. Then triple bond, we have this class called alkyne. And the functional group is not called alkyne, but alkyna. Okay, but worst come to worst in the exam, you forget, then you just say that it's alkyne, okay? Or you just call it an alkene. But the correct functional group is alkena and alkana, okay? Anyway, take note that the double bond and triple bond later, when we are learning in the naming, it must be in the main carbon chain. Okay, it has to be in the main carbon chain for all double bond and triple bond, because later when we learn naming, there's something called prefix, stem, and suffix. The problem with these two groups is that there is no prefix name. Okay, so therefore it will always be in the main carbon chain. Next, if I have OH, the class of compound, okay, the OH I'm referring here is a ROH, alkyl group bonded to OH, not a benzene ring bonded to OH. Okay, if it's a benzene ring bonded to OH, then we call it phenol. So it's not an alcohol. But if it's alkyl group bonded to OH, then we call it the class is alcohol. The functional group is OH or called hydroxyl. Okay? And a hydroxyl can be in the main chain or it can be a substituent. So it depends. Next, if I have something like this, there's sandwich. I have 2R group. And then in the middle, I have just a single bond O. It's a single bond O. So like O is connecting both R together like that. It's called an ether. The class is an ether. The functional group of this O here is called alkoxy. So alkoxy is actually something like this here. R and O. So you get alka-oxy. So alkoxy. Okay. So the way to name it is something oxyalkane. So if you look at this, if two sides, the longer side is 2 carbons, so it's oxyethane, then this substitute, this thing is so methoxyethane. So it's it take on this alkoxy functional group. The class is called ether. Okay, next we have aldehyde. Aldehyde, right, you will start to see COH. Now, aldehyde is the class. The functional group is just this part here, and it's called carbonyl. But for aldehyde and ketone, both of them has the same functional group, which is the CO, and that's the carbonyl. But the difference is that in the aldehyde, if the class is an aldehyde, this group is a H. If the class is a ketone, then that group or both groups are alkyl group. Okay, so for aldehyde, one of the group will be at least maybe an alkyl group or a H. Okay, so this side can be an alkyl group, can also be a H. For this case, but at least, one of them must be a H. Then it's an aldehyde. So usually I will just take as is a COH as an aldehyde, and a ketone will be RCOR. Okay, that CO in the middle is called a carbonyl. C double bond O is a carbonyl. Okay, and that's the functional group. Now, what's the thing about the naming is if you look carefully, the aldehyde carbon is one of the chain. It's one of the carbon chain later. And because it's one of the carbon chain later, I always have to count this carbon as number 1. Forever, the aldehyde carbon is always at number 1. Unless, unluckily, it's with a carboxylic acid. If not, it will always be number 1. So therefore, nobody will call something 1-propanol because default is 1. So, or you won't call proper 1 now. There's no need to tell people it's 1 because it's default as number 1. So that number, later when we learn naming, the number is only put in meaningfully if it leads to greater clarity. If there's no ambiguity, and there's no ambiguity, then there's no need to clarify, then there's no need for a number. But if there's ambiguity and there is a need for you to be clearer, then you have to put in the number. Okay? So for this carbon, it's never going to be a number 1 because on the left, there should be some C's, on the right, there should be some C at least, so it will never be number 1. So there's a need to tell me where is it. Then there's a need for the number if there's an ambiguity. Okay, so you'll find that, right, like propanone, there's no ambiguity. There's no way anybody can draw a 3-carbon ketone besides a propanone. Same, there's no way anybody can draw a 4-carbon ketone unless it is a butan 2-one. So there is no need to tell people this is number 2, butan 2-one, because there's no way to draw anything else that is not butan 2-one if you have 4 carbons only. And there's no way to draw anything except propan 2-one if you have only 3 carbon. Okay, but if there's now 5 carbon, then it is a bit different. When there's 5 carbon, so I can be doing something like this. Then there's a difference now. Because if I don't give a clear instruction, some may draw it on number 2. Some may draw it on number 3 carbon. Like this is 1, this is 2, right? And then 1, this is 2, this is 3. So some may draw it on number 3, some may draw it on number 2. So it is ambiguity here. So I have to give you very clear instructions rather than just tell you, can you draw me a 5 carbon ketone? Because that will lead to different drawing from different people. But if I say, oh, can you draw me a 3 carbon ketone? Everybody around will draw the same ketone anyway. So if I say, oh, can you draw me a 4 carbon ketone? Everybody will get the same ketone anyway. So there is no need to state the number. Okay, but if I say, oh, draw a 5 carbon ketone, then I may have some drawing me a 2 pentanone. I may have some people drawing me a 3 pentanone. So there is an ambiguity there. So instead of giving such instruction, I have to be clearer. I say, oh, can you draw me a pentanone? Can you draw me a pentanone? So that everybody get the same, will be giving me the same picture. Okay, so that's it. Okay, next one, carboxylic acid is the class, the functional group, which is the COOH we have seen in acid base, which is always a weak acid, is called a carboxyl. Okay, a carboxyl is a weak acid, and there's organic acid and the COOH here. Now, again, okay, if you see carefully, what is on here, it could be a H, it could be a C. Okay, let's say it was a C, some carbon. So you can see the COOH is going to be part of the carbon chain. And again, because it's at the H, it will always be number 1. So nobody will say, oh, 1 propanoic acid, because there's no way to draw another propanoic acid besides putting the carboxylic acid at number 1. Okay, so the only issue is when aldehyde and acid are both present. Then how? Who shall be the number 1, right? So if carboxylic acid and aldehyde both are present, then carboxylic acid is higher priority. It will be number 1. And then so this one, too bad, it will be given some other name. So I will just show you what it will be called. Okay, so let's say if this structure really has an aldehyde together with an acid. But when I'm trying to number it and later I try to call it, I have to call this number. Somebody has to be number 1 and priority has to be to this acid. So if this is 1, this is 2, this is 3, and this is 4, right? So be it, it will be number 4 because priority is to the acid. So this is a butanoic acid, correct or not? Because it's 4 carbon. Then I'm going to tell people, hey, there's something here. I cannot call it butanol-aldehyde, right? So I will have to call it 4, and number 4, there's this carbonyl group for 4 carbonyl. Oh, sorry, it's not called 4 carbonyl, it's called 4-oxo butanoic acid. Okay, so later explain why is it called oxo. Okay, 4-oxo butanoic acid. So basically what I'm trying to tell you is that usually they are always number 1, unless the two meet together. Then carboxylic acid will be number 1, and then the other will take on whatever number is along the way, as we numbered in sequence. Okay, next we have a group called ester. The class is ester. The functional group is, we call it ester also. The functional group is also ester. Can you please update this? So it's ester and functional group also ester. And we have this RCOOR. Now this can be a H, this can be a H, it can be a R, but most of the time it's R. So RCOOR. So it looked like the acid, but now the H of the acid was replaced with another alkyl group. Now do not mix up ester with ether, because ether was the single bond one. Okay, and then this is COOR. Now remember, and another thing is that there's no such thing as double counting. So, if there's this group is like that, right? Altogether, RCOOR is called an ester. So you cannot break it out and say, oh, I see a carbonyl and I see an oxo. No. Okay, it is together forming a group called ester. Now, the same for acid. You look at the acid, you cannot tell me, oh, I see an acid, I also see a carbonyl, I also see a hydroxyl. No, no, no. So once they are together and you classify that as this group, it is one group on its own already. So you cannot double count it as a carbonyl, hydroxyl, carboxylic acid, everything is there. No, okay, it is just a carboxyl. Then this is an ester. Okay. Now, then another class is called amide. Amide has a C double bond O with N. C double bond O with N. Okay. Amine will be just C single bond with N. So that's the difference. One is C single bond with N, one is C double bond O with N. Amide, the functional group, this functional group is called amido. Okay. Amine, this functional group is called amino. The class is amide, the class is amine. So worst come to worst during exam, if they ask for functional group and you cannot remember, then but you know it's amide, just write amide. Okay, because you can't remember amido. But so you just write amide. They can accept it, but it's not the best answer. The best answer is amido. Halogenoalkane, I think we know they are halogens, which are the group 17 atoms. So we are halogenoalkane. And arenes is the benzene ring. Arenes is a benzene. But if it is a pure benzene, the formula is C6H6. But if benzene is a substituent or a benzene is substituted, it could be it's a substituent or is substituted with something, let's say in a Cl, then it's C6H5 because that one position of H is replaced. Okay, understand? So note the difference. Okay, so when we do a naming, we have three parts to a name, which is the prefix, the stem, and the suffix. Okay, so stem and the suffix is the most important. So I always align the stem and the suffix as a tree. The tree trunk is the stem and the suffix. You take care of a tree trunk first because that's the most important. Then the prefix are like my apples hanging on the tree. So they are called substituents. They are not called apples. Okay, they are called substituents. So when we do naming and drawing everything, we always look at the stem and suffix first. Then we put in the substituent or the prefix. Okay, something like this. Remember the apple tree. Okay, so we have stem is telling us how many carbon in the longest continuous carbon chain. So the key word is longest continuous carbon chain. That includes the functional group. That includes the functional group. And if there is an alkene, alkyne, it has to be inside. It has to be inside. It cannot be the apples on the tree. It has to be in the stem. Okay, now if there's more than one functional group, then choose the highest priority to take on. Okay, then the other lower priority then will be the substituent. So we have the longest continuous carbon chain forming our stem, and then the suffix, which the name that we got adopt, is like the functional group family name. Understand? So for example, remember functional group family name. So if you look at the alkane, it always ends with A-N-E. Alcohol will end with O. Okay, aldehyde will end with A-L. Now, okay, same AL, so AL. Ketone will end with on. Okay, that's the name that it ends with. Acid ends with oic acid. Okay, how to remember? Very simple. Name the alkane first. So let's say anything that you like. Let's say you like butane. Name the alkane first. Take an eraser, clean away the E, and put in the suffix. So if the suffix is an acid, then put in oic acid. If the suffix is an ketone, then put in on. If the suffix is an alkene, then you got to change the E. Alkene, a bit tricky. So if the suffix is alcohol, then O. If the suffix is amine, then put in the word amine. I mean, if the suffix is an amide, then put in the word amide. If the suffix is an aldehyde, then put the Al. Okay, so usually we will just write back the alkane name, clean away the only for alkene and alkyne, then got to change this part. Okay, so after you find the longest continuous carbon chain, including the functional group, then what we will do is we'll, as much as possible, try to number the carbon in that chain, giving the smallest number to the highest priority functional group. So smallest number to be given to this part, not to the substituent or the apples on the tree. That one is not important. Okay, smallest substituent given to the stem as functional group that was in the suffix. That was in the stem and the suffix. Okay, so we number it such a way. Now later we look at the order or the priority, but now we look at next is then the rest which are not included in the stem and suffix that we have identified will be all called prefix. They will be all substituents and they will all be indicated by prefix name. And every prefix need to have a name and you need to have a number to tell me where to find it. Everyone has a name and has a number, just like your house. Everybody's house has a unit number or has a block number or has somewhere some number so that people can find you. Okay. Okay. So priority. So those are the functional group. Okay. So aldehyde highest carboxylate highest priority and so on and so forth. Okay. So that's the priority. Alkene, unfortunately, because if you look at every of the column, there's a prefix and a suffix. That means they can be a prefix, they can be a suffix in a way, right? Okay, so if they are the suffix, that means that inside the main stem and the trunk of the tree, then you put all these names in, right? If they are hanging as a substituent, just like the apples, then you use this name, correct? But if you look carefully, alkene does not have a prefix name. Alkyne also don't have. So they forever must be in the suffix. They must be in the longest continuous carbon chain, including the functional group. Okay? And then another group of substituent, you'll find that they only have prefix and they never have any suffix. Means forever, they will always be substituent like chloro, fluoro, bromo, methyl, ethyl, propyl, the alkyl group. So they are usually only having prefix name. They don't have suffix name. Okay, alkyl a little bit subjective because usually it forms the longest continuous carbon chain, but things like halogen definitely is going to be a substituent, and alkoxyl, which is in the case of ether, like methoxy, ethoxy, it will always be a substituent. Okay, so we'll try. Okay, first step, find the longest priority functional group. Then determine the longest continuous chain that includes the functional group. I need a drawing. Let me include a drawing, then you can understand what I'm talking about for some of you. Let me anyhow draw something. Okay. Okay, so longest continuous carbon chain. Wait, let me make it even longer. Okay, longest continuous carbon chain. So, sometimes it may be drawn in the form of straight line. Sometimes you need to twist and turn a little bit. So example that you may have to twist and turn a little bit. Let me see whether there is any example that can show some twisting. Not here, but maybe another exercise that I have. But just like, sometimes it's given in form of straight. Sometimes you may twist a bit and double check. Okay, sometimes you may twist here and there and just make sure it's not the longest. Okay, so you need to be able to look at all the possibility and then choose the longest chain. Okay, but most of the time, you cannot take for granted it's always going to be the one that is presented to you in a straight manner. Okay, so I need to put it on my H. So longest continuous chain. with the functional group. So longest is this. I have so many functional group. I have an OH, I have an oxo, I have a chloro, I have a carboxyl. So I choose the carboxyl because it's the highest priority. So I take this as my trunk of the tree, remember? Okay, so I will call this 1, 2, 3, 4, 5, 6, 6 continuous carbon chain. So hexane, I remember hexane. So I named the longest continuous carbon chain that includes the acid. So I'm going to clean off the E and put in oic acid. Now I don't need to tell people it's number 1 because it's default 1 for acid. So I'm going to put in, so I'm going to label it number 1, and then 2, and then 3, and then 4, and then 5, and then 6. So when we number the chain, we have to number in such a way that the priority functional group will be given the smallest number. So that's why I'm numbering from right to left. But if I do left to right, it'll be 1, 2, 3, 4, 5, 6. Then this becomes 6. My functional group becomes 6, which is not correct because the highest priority functional group must be given the smallest number. So it'll be 1, 2, 3, 4, 5, 6. And so it will always be 1 for acid. Then replace the E, which I did just now. I spell an alkane. I will clean off the E and I put in the name of the functional group, which is oic acid. Then after that, I have some apples on the trees or the substituents. So I have 1, I have 2, I have 3, I have 4 here. Okay, so what are the prefix name? I need to use that prefix name. So the name of the prefix must be, we have some idea first. So OH is called hydroxy. This is hydroxy. This is methyl. This is chloro. This is oxo. And they tell me the name of the substituent must be arranged alphabetically, not by 1, 2, 3, but by A, B, C. So I have to apply them, name that alphabetically. Okay. And not only that, I have to use numbers to indicate their position. Okay, now if the same group appears twice, then I have to use di and tri to explain. So if the group appears twice, I have to call dichloro. If it appears thrice, 3 times, trimethyl. Now take note the D and the T is not part of the alphabetical selection. So when I say arrange in alphabetical order, let's say dimethyl. I don't look at D, I look at M. Understand the di is not included in the judging of the alphabetical order. Okay, so if it's a trichloro, I cannot look at T. I should be looking at C. So it will be alphabetically ordered C first. Okay, so in this case, definitely C, then H, then M, then O. Okay, I'm going to write down alphabetical order. I need to tell people where to find C. So I'm going to tell people it's at number 2. Okay, so it'll be 2-chloro. Okay, now take note what I'm doing. I'm putting a dash. When do I put dash? When it's between a number and an alphabet, then we put a dash. If it's between a number and a number, then put a comma. If between alphabet and alphabet, there is no need to put anything, and by right, there's no space. Alphabet and alphabet, then just be okay, nothing one. There's nothing. So 2-chloro, and then after C, it should be H. So dash, why dash again? Because I'm going to put in the 5 now, between alphabet and a number. So 2-chloro, 5-hydroxy. Then what else do I have? CHM. Oh, okay, M. Dash 4 again. Why? Because I'm changing the number again. 4-methyl. Then some more. Oh, there's an oxo here. Okay, so remember, if it's a ketone or a carbonyl, it was called oxo. If it's not part of the functional group, if it's a substituent, then it's called oxo. If it's a prefix, it's called oxo. So it's 3-oxo. Then now I put it in, I join it back. So hexanoic acid. I mean, if you really want a space, then you just put a space. So something like this. So the idea is, summarize, choose longest continuous carbon chain that has the functional group that has the highest priority. Okay. And always give that functional group smallest number possible. So you can only number from left to right or right to left. So whichever direction you adopt, it must end up giving smallest number to the functional group, not the smallest number to the substituent, to the apples. Understand? They are not important. So smallest number to the main stem and suffix. And then along the way, if the substituents end up with whatever number, so be it. Just let them be. Okay, then when we number our substituent, we use the prefix name. Prefix name. And then, right, we have to tell people where to find all these substituents. Where am I supposed to find chlorine? I tell people where by putting a number. If I have two chlorines, there should be two numbers. Okay, so let's say if both I have this group change into chlorine, let's say this group over here, the OH, I change it into chlorine. That I have to say that I have a dichloro now, right? And I cannot just say 2-dichloro. I must say 2,5 dash dichloro. 2,5 dash dichloro. If now I change to chlorine. So if the group appears twice, you have to have two numbers, even if the group appear twice on the same carbon. So let's say it's all on carbon 2. You still need to put down 2,2 dash dichloro. Okay, everybody has a number. Every substituent has a number. They are not going to share. Okay, so 2-chloro, 5-hydroxy, 4-methyl, and 3-oxo. And why am I like having number like jumping 2, 5, 4, 3? Because I am not supposed to arrange according to numbers. I am supposed to arrange according to alphabet. So C comes before H, before N, before O. Okay, if you have di and tri being used, those are not included in the judging of the alphabetical order. Okay. All right. So if a functional group is not in the terminal position like an aldehyde, then the position will be trying to be given by a smallest number. So usually we will try to put it inside the name, like something like this. Oh shucks, can we just remove this? There's no butanone. Remember, it's butanone. So it's called, let's say, pentanone. This example will be better. Pentanone. So you can see alphabet, number, alphabet. So I need to put dash. So that's why I put a number between the two dashes and the functional group inside. Okay. Now, sometimes they put a position at the start of the name, possible, but if there's only one group, for example, if I have an alcohol, propanol. So I don't want to write propan 1 or can, then you write 1 propanol. Now you can only do that if there's no substituent. But if there's substituent, the substituent should be taking this position all in front. So you can't do that anymore. Okay, you can only do 1 propanol if there's no substituent. So in this case, the longest functional group is the functional group with the carbon chain is just alcohol, and the rest are non-functional, non-substituent, are just hydrogen. So there's no other substituent, then yes, 1 propanol. But if there is a substituent, just change 1 to a chlorine. Then you can't 1 propanol, because that position here now is for the chlorine. So it's 2-chloropropan 1-or. Okay? So if you are thinking it's so confusing, then always put it inside then. Just always put it inside. Okay, so the name of the branch or the substituent, which we call the substituent, should include the name of that substituent. Number of branches. If the same substituent appear more than once, then you will have to include it in the name, telling people that it appeared twice or thrice. And then there should be a number, and the number should be whatever number it ended up with after you gave the smallest number to the highest priority functional group. So the position of the functional group always has a higher priority over anything else, like an alkyl group, like a chloro, like a hydroxyl, or etc. But if that's the functional group, okay? So in this case, our functional group in these examples are all alkyl group. So you can see they are all substituent, are all alkyl group. So definitely, my alcohol will have a higher priority. Okay, I think there's something wrong. This should be 2-methyl propan-2-ol. There's no 1-methyl propan-2-ol in the world, I think. So it'll be something like this. Okay, 2-methyl propan-2-ol. Can you update this? Okay, next. Before I go to name ester, because ester is really quite different, and amides and so on. So let's look at some examples first, which are easier. So in this case here, let's look at some examples. This one, the longest continuous carbon chain is this. So it's just an alkane. Alkane has no functional group. Okay, so 1, 2, 3, 4, 5. So since alkane has no functional group, then we don't need to number smallest given to the functional group because there's no functional group. So if that's the case, there's no functional group. For us to number it as small as possible, then we try to give the smallest number to the substituent. Then 1, 2, 3, 4, 5. I repeat that we only give the smallest number to the substituent now because the main alkane has no functional group. So in the case there's no functional group, then we give the smallest number to substituent. But in the cases where there are functional group, the smallest number should be given to the functional group and not the substituent. So whatever the substituent ended up with after you gave the smallest number to the functional group, so it will be it. Okay, so it will be 2, in this case 2 and 3, and it's the same group, so it's a methyl group, and this methyl group appears twice, so it's called dimethyl. And I need to tell people where is it. So it's 2, 3, between numbers is comma, between numbers and alphabet is dash, so 2, 3 dash dimethyl pentane. Okay, this one over here, can I don't take the alkene? Cannot, I can't don't take the alkene because alkene, right, doesn't have a prefix name. It doesn't have a substituent name. So I have to take the alkene as my longest chain. So anyway, there's a functional group. That functional group is called alkene. Alkenyl, right? I got alkenyl here. So I should give smallest number to alkenyl. So left and right, I should number from right to left and not left to right, because when I number right to left, it becomes 1, 2, 3, 4, 5, 6. Alkene is now at 2. But if I number left to right, 1, 2, 3, 4, 5, 6, alkene is at 4. So I can't give alkene 4. I must give it the smallest number. So I will take the red one. So it's a 6 carbon hex. At number 2, there's an alkene. So I'm going to tell people it's at number 2 and not at number 3 and not at somewhere else. So hex 2, and the functional group is, or the suffix of the functional group is alkene. So hex 2 in. So the 2 is within the stem and the suffix name because there was a substituent. If there's no substituent, I can call it 2-hexene. But there's a substituent, and the substituent will have to take up the space in front. And so by numbering that way, my substituent is now number 5. So 5-chlorohex-2-ene. Okay, next. Okay, next. So longest continuous chain with the functional group, I have to take the alcohol. 1, 2, 3, 4, butane. Okay, so remember, spell butane. First, clean away the E. Spell butane first, clean away the E and put in all, right? But I need to tell people where's the alcohol, so there's I squeeze in the number. Okay, so it's butane 2-all because I have to give smallest number to OH, so I call it 1, 2, 3, 4. So butane 2-all, and as a result, my substituent is now on number 3, so 3-methyl. Okay, the next one, bromobutanoic acid. So I could number 1, 2, 3, 4, but can't because the carboxylic acid is my functional group. I must give it the smallest number. So 1, 2, 3, 4. So 4 butanoic acid, right? So but no need to say it's a butan 1-oic acid because it's always 1. So then I have bromo on number 3. So 3 bromo butanoic acid. Okay, so I will look at the exercise 1 and finish it. Oh, I can't finish it because there's ester. I'm not going to do ester today. Okay, so name the organic compound, longest continuous carbon chain. Okay, and I have the functional group double bond, and that's my substituent. 1, 2, 3, 4, 5, 6. So it's a hexene, right? But I need to tell people where's the in. So it's 1, 2, smallest number to the double bond, 3, 4, 5, 6. So it's hex 2 in. Then at number 3, there is a methyl group. 3 methyl hex 2 in. Okay, the next one, longest continuous carbon chain. So 1, 2, 3, 4, 5, 6, all alkanes. So no functional group, we just call hexane. So if no functional group, smallest number given to substituent, then 1, 2, 3. So at number 2, I have a methyl. At number 3, I have a methyl. So 2, 3, dimethyl hexane. Okay, now, so you know how to name, you should know how to draw. It's the same thing, it's together. You can't know how to name without knowing how to draw. You can't draw if you don't know how to name. So draw the full structural formula of the organic compound. When we draw, we don't follow front to back. We do the tree trunk first. We do our stem and suffix first. Then the prefix fill in. So when you draw a tree, you draw the trunk first before you draw your branch. So it's the same idea. Okay, so draw pen 2 in first. Now read the question, full structural. So you don't like it, also need to show every bond, 1, 2. Okay, and so 1, 2, this is number 2, 3, 4. And number 4, there's a methyl group. So I have to show all the bonds. Check every carbon, 4 bonds. Check every carbon, 4 bonds. Don't give me fishbone like this. This is called fishbone. Give me full structural formula by putting in the H. Now, if you like to draw fishbone, then make sure by exam it has to be with the H. Exam, any missing H structure is wrong. Okay, so that's the structure. Now, write the condensed formula. What you see is what you write. So I see this first. I see a CH3 first. Then I see a CH. Then I see a CH. And I see a CH, another CH3 hanging there. So I can put CH bracket CH3 if I want. Then I see a CH3. So I put that there. So that bracket is for this one. Okay. And then, so you draw it again. I will draw another one, which is C. I will skip B first because I haven't covered ester. So C, I must not start with hydroxy methyl, but I start with propanoic acid. So I will draw propanoic acid 1, 2, 3, 4. So if you are like me, then it will be wrong because the full structural formula needs you to expand the O and the H. So it has to be like this. Okay, and at number 2, there's a methyl. So if you happily draw this, also will be wrong because it's full structural. So you have to draw this out. And at number 3, there is a hydroxyl. So again, if you put in your hydroxyl like this, it will be wrong because you have to show the bond OH. Okay, then top up all the carbon with mixture 4 bonds and then check. Then fill in the H, not give me fish bones. So give me all the H. Okay, and then now let's write the display formula. What you see is what you write. I see CH2. I see a OH. So if you like, you can put bracket. If you like, if you find that it's clearer to you. Okay. Okay, but you don't need to do the coloring what I'm doing. Okay. Then after that will be CH. Then you find that very confusing. I'll show a bracket, I'll do a bracket, then a bracket CH3 and then COOH. Okay, that's the condensed formula. Okay, so with that, we've covered a little bit basic of naming, but honestly, it's not enough. So we will have to try some questions, then add on the halogenol, esters, amide, amines, nitrile, ester, ether, and then practice more questions. Okay, so for today, we just look up to here. And then if there is another video, then we'll do more questions.